Today's lesson is page 162, section 2.1, Linear and Quadratic Functions and Modeling. This is part 1 of the lesson. The first thing that we're going to talk about is what is a polynomial function and what makes a function a polynomial function. The notation form, which is the first thing listed here, looks very confusing. I'll try to simplify it for you. A to the power of n, or a to the power of n minus 1, these are just coefficients, or numbers that are in front of the variable. A to the power of n could be 5, for example. A to the power of n minus 1 could be negative 2. Now, x to the power of n is going to represent our highest power with the variable. X is going to be our variable in this situation. So x to the power of n could be x to the power of 4. Then we will decrease the power by 1. So x to the power of 3 could be xn minus 1. If you plugged in 4 for n, that would get you 3. And you could do this all the way down. Now, it doesn't have to necessarily go in order from 4, 3, 2, 1, and to no power. It could skip one of these numbers at any time. What we care about, for the most part, is what is our highest power. That's going to be the degree of the polynomial, the highest power. So in the example above, the degree of the polynomial would be 4. The leading coefficient is the number in front of the variable with the highest power. In this case, our leading coefficient is 5. Not that the rest of this doesn't matter, but a lot what we deal with is looking at the highest power and the leading coefficient. So make sure, if they are not in order, make sure you realize what is going to be the highest power and the number that goes with it. Here I have two examples of non-polygonal functions. Why are they non-polygonal? One way I can write a square root is to the power of 1/2. The power of 1/2 is what creates this not a polynomial function. The powers always have to be positive integers, which means positive whole numbers. So 1/2 does not work. In the second example, 3x is okay, but 2x to the power of negative 4 is not. The negative 4 is what causes this to be a non-polygonal function. Next thing we're going to talk about, and what we're going to focus on in part 1, is what is a linear function. Again, this should be totally reviewed from Algebra 1 and Algebra 2. Two different ways to write it. The one on the right is probably the way we learned it back in Algebra 1. Y equals mx plus b, where m is our slope and b is our y-intercept. You will also see this in your calculator as f of x equals ax plus b. Again, a is your slope, b is your y-intercept. The number that goes in front of x, or the coefficient in front of x, represents your slope, and then the constant at the end is your y-intercept. Finding slope, or average rate of change. There is a number of different ways that we talk about slope. You will hear average rate of change is another one of those. Now, the example on the left is the formula that we learned, again, back in Algebra 1 and Algebra 2. You have the change in y over the change in x, or rise over run. So you have your y2 minus y1 divided by x2 minus x1. And it doesn't really matter which number you consider to be y1 or x1, but they do have to match up vertically. Common mistake is putting the x's on top and the y's on bottom. Make sure the y's go on top. Another way to write this, and you're going to see this as you get into more of pre-calculus and into calculus, is f of b minus f of a divided by b minus a. Again, f of b is just a y value. F of a is a y value. b and a are x values. Written here below, you can see f of 2 equals 5. 2 represents your x, 5 represents your y, just like over here when we have it in ordered pair form. Down here, f of 8 equals 10. 8 is your x, 10 is your y. What I have done here is set up the problem to solve for slope. Notice I use 10 first. If I use 10 first, I got to use 8 first on the bottom. Take 10 minus 5, which is 5. 8 minus 2, which is 6. Simplify the fraction if you can. This one cannot be. If it is an improper fraction, like for example 4 over 3, leave it as an improper fraction. Now, the last thing we're going to talk about today is writing a linear function. So what they will most likely do is give you two ordered pairs, or in this case, f of negative 5 equals negative 1, f of 2 equals 4. These ordered pairs, again, x is negative 5, y is negative 1, x is 2, y is 4. We want to put this in the form y equals mx plus b. So we have to find two things. First, we have to find the slope. Second, we have to find the y-intercept. Here's the process that we're going to use. So, first, we're going to find slope. Just like we did on the previous slide, you're going to take your y's, subtract them on top, take your x, subtract them on bottom, and simplify the fraction if you can. So, what I did, I started with negative 1 first, then I subtracted 4. That actually got me negative 5. But I took negative 5 on the bottom minus 2, which is negative 7. As you all know, two negatives will cancel out, so I simplified it already to be 5 over 7. So that is going to be my slope. So how do we find the y-intercept? Here's what I'm going to do. First thing I'm going to do is plug in 5 over 7 for m. So I have the equation y equals 5 over 7x plus b. Now, I need to figure out what b is. I need a value that's x and y that is a part of the linear equation. I have two choices. I have negative 5 and negative 1 for x and y, or I can have 2 and 4. Choice is yours on which one you want to use. I chose 2 and 4. Probably just because they are positive. I don't like to use negatives if I don't have to. So I plugged in 4 for my y, plugged in 2 for my x. Now what I'm going to do is solve for b. First thing, 4 equals 10 over 7 plus b. So next step, subtract 10 over 7, which is going to be 18 over 7. Again, the best thing to do is leave it as an improper fraction. If you put it as a decimal, the problem with this one is 7's in the denominator and the decimal is kind of messy. So it's easier just to leave it as a fraction. So the last thing I'm going to do is plug in 18 over 7 for b, and this is my final equation. Y equals 5 over 7x plus 18 over 7. Again, don't be afraid when you get fractions as an answer. That happens sometimes. Your homework for tomorrow will be page 175, 1 through 12.